overview of how I work with professional and elite athletes to bring them to the next level of performance. Robin Stevens here, who is the top Olympic female race walker on the Olympic team. And we're going to be working with fixing her body. We're body mechanics. We help coaches and athletes get the job done. Period. That's our job. We are high performance kinesiologists. Okay, so the first thing I want to call your attention to is understanding what the SAID principle is, which is anybody in my business knows that it means specific adaptation to imposed demand, or the body always adapts to exactly what it does. So if that you're practicing something bad, it will get very good at practicing something bad. Okay? If that you're sitting all day at your desk, you are going to be a very good sitter. Your body will adapt to sitting. It won't work well to athletics, but you're going to be a great sitter. Okay? Efficiency. So what we're always looking for is the efficiency of movement. Okay? We need to make the body move fluidly so it can move fast, get ground force reaction. So you push into the ground as you go forward. That's ground force reaction. That's going to propel you forward. And the body drives that ground force reaction. So to get it correctly, the elements of efficiency are perfect form, or the perfect rep principle. Dynamic postural alignment. So you've seen static alignment where they stand you up and turn you to the side. Look at, see if your ear and your hip and your shoulder, your knee, all that is in line with your ankle in a straight line. And dynamic postural alignment is where everything should be in motion, whether you're a baseball pitcher, a hockey player, a basketball player, a 100-yard Olympic sprinter, a race walker. Anything is dynamic postural alignment. Each body and each sport has to have the correct muscle imbalance, muscle balancing, and joint alignment so those joints can communicate with each other. And synchronized respiration. Synchronized respiration is the ability to breathe with your movement. Okay, so the breathing is working with the movement, and that's a whole exercise in itself. And the balance of tension and relaxation. So there has to be enough tension for the body to hold itself upright. If it's too much tension, it's going to slow down the limbs. So if there's too much tension up here and you're tight, this can only go so fast. Loosen it up and bang, 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 it can fly. Every rep, you're using up energy and you only have so much battery. Okay, by the end of the race, you're going to get tired all over the body if you've got anything holding you back. So a balance of tension, it have to be relaxed enough, but you still have to have enough tension. So that magic middle. Enemies of efficiency. Startle reflex, physically and mentally. The startle reflex is what you do if somebody's about to attack you. You're going to protect yourself. You automatically go into that womb position, into there, and you're protecting yourself. The shoulders come forward, the head goes down, you go into the curl. Forward shoulders are rounded. That's a big part of the startle reflex. That can be caused mentally or physically. So mentally, if you're in a race and you're worried that you're not going to do very good, and you're worried about this person or that person, you're not in your game, you are going to have more startle reflex, and you're going to tighten up, and you're going to slow yourself right down, and you're using up your battery. And so at the end of the race, you've used too much energy early on. We come down to tech neck is one of the things I've added to startle reflex, because this is today my biggest problem with athletes. They're in the startle reflex constantly. And the more they're on that damn phone or sitting like this on a laptop instead of sitting ergonomically correct with the shoulders back, they're living in a startle reflex. And now that's going to go out in their performance, and that's a deficit to that movement. SMA, sensory motor amnesia. Sensory motor amnesia was coined by Thomas Hanna in somatics. Somatics is the brain to the body. Now, when a muscle is not used because another muscle is overused, that movement pattern ceases to exist, the brain stops working it. And you lose that brain to body at that part of the movement. One of the areas that we will check how the leg is the gait, if I can't get a good circle, so a lot of people, this is what we call knee circles. So in that position, so we'll find people cutting this corner. See how I'm cutting the inside corner? So by cutting that inside corner, I have sensory motor amnesia. My brain has forgotten how to get that corner. Now put all those movements in your body, knees, arms, ankles, hips, rib cage, BSD, that's my little thing for butt sitting disease. So the majority of people I'm working with today versus 25 years ago is sitting at a computer. You know, our whole workforce has changed to sitting or standing at a computer. And we have things that we didn't have 20 and 30 years ago, like phones. You have to realize how new a phone is, a phone, and laptops and computers. We're in an age of where tech has created messy bodies. And so as that I'm thinking about an athlete, there are lots of things that are going through their mind. That's always going through my mind when I'm writing a program. Okay. The next thing, I want to give credit where credit is due. I've learned most of what here from all my education from different people. That was a lot of from Z Health and Dr. Eric Cobb, who I learned the majority of that many years ago. That's one of the top neuroadaptation to the brain and body through exercise, and it's a high-end trainer educational process. The inner unit is for spinal integrity. The outer unit functions as both a phasic system and a stabilizing system consisting of, and we're going to go into that in a minute. So inside your body is the inner unit. And the inner unit is how your core, abs, back, and the spine, how it keeps the spine in alignment. The inner unit is most important. Without the inner unit, the outer unit will not work right. And if the outer unit overpowers the inner unit, we're going to have trouble in performance and pain. So that is all these muscles. We got rotatorius, multifidus, and how they skip, and semispinalis, and all these muscles that kind of fan out, protecting that spine, keeping it up in the air. So when we're exercising, two of the things that we teach everybody is tall spine. You have to be in a tall spine because you want the discs at full, and you want those muscles to hold those discs up. If they're not up, then your axis of rotation, okay, if you're like this or you're crunched, you're rubbing those discs and those vertebrae together, and it's friction and you can't go fast. So if you're up here, now you've got this. Now you need to be able to do this with a balance of tension and relaxation. So you have to practice being up. So all our weightlifting, any type of training, is with what we call tall spine, because we're working the inner unit to keep it tall. We want that space so there's no friction when we turn. No matter what turns, we don't want friction in the spine. So first is the deep longitudinal system. These are four here are of the outer unit. I just told you about the inner unit. So in the outer unit, we have the deep longitudinal system, which I'm going to go over the last, the posterior oblique system, the anterior oblique system, and the lateral system. Those four systems control the stabilization of our body, keep our body in order, and produce locomotion. Almost all locomotion comes from this. The legs and the arms are just appendages of the motion of the body. Sergei Gregovetsky wrote the book, famous book for all of us, that turned our heads around 30 years ago, called The Spinal Engine. And how the spinal engine, it's an incredible piece of research that changed physical therapy and sports performance, especially at the high level, into understanding that the rib cage is the master commander of speed and movement, especially in running and walking. Okay, so that's a huge area. The posterior oblique system, I'm going to come over here, and this is the posterior oblique system. And I'm only going to take 2 muscles in the posterior and 3 muscles in the oblique. There are more, but these are the biggest ones and the dominoes of this. So in the posterior system, the glute maximus and the lats control the posterior chain of the first half of propulsion. So the lat attaches to the arm and goes down, connects to the thoracolumbar through here to this spine and this fascia that connects to that spine. That fascia is like a big web here and the muscles go into it. And down here we have the glute maximus. Those two, okay, I'm going to turn around so you can see what happens. So in gait, as that I'm in this position, when I get to heel strike, what's going to happen is this glute is going to contract, while this arm, the lat, is going to contract and pull the arm back and the body forward. That is the 2 main muscles that propel forward. Now what happens from the deep longitudinal system is that's going to affect on this phase leg how this bicep femoris, outside hamstring, which attaches there, and this perineal and the anterior tib gets the heel in the right place. Okay, through that, if this is faulty, there's going to be a problem. So how is this faulty? People who are stuck in the posterior chain are like this, and they're pullers. They're pulling themselves across the floor. And they're doing this, and they're just pulling. The pelvis is forward, all this. Those are pullers. Well, by the end of the race, they're going to start slowing down because these suckers are exhausted. To get past that, to get into the anterior obliques, the adductors with the same side internal obliques, which I have backwards, they will be going this way, and the opposite side external obliques, which are the pink ones here. Those are the ones I meant. So we have internal obliques, which are on the inside, and they attach here, and they attach from the fascia here and pull up through here. And they will, somebody that's interior oblique dominant will be like this. Somebody, the external obliques are on the outside, and those pull this way. They go in the opposite direction, and they pull you down this way. So that's important to understand. These work, obliques and the groin muscles work in concert to push. So to push, you change from here is the stuck posterior runner or race walker, and here is the stuck anterior. They're going to be pushing. So now I'm pushing across the floor. Posterior pulling. Efficient race walking is push and pull. So as this pulls, when I get to stance, this shuts off. For that moment in time, my bones are holding me while there's a transition of muscles shutting off and other muscles turning on. And then I go into push. Adductors and obliques are going to start pushing me forward. Okay? So a good race walker, good runner is going to have both more of an even posterior, it's going to go from pull to push. So actually when one leg is pulling, the other leg is pushing. And that timing separates the best from the also-rans. Okay, that's really important to understand, is that evenness of push-pull. Okay, and that's why these slings, that energy, produces energy through the thoracolumbar fascia. Both of those are producing energy. So when runners get that runner's high, they're in centrifugal force, and it feels like they're not running. It doesn't last long, but they're not working a lot of energy because all those slings are working. It's all free energy. So as in the oblique chain, I'm going to take it up a notch further. So as I go into this, and this is back, as here's where my pecs attach, come down through the abs, through the fascia, into the adductors, into the quad. So what happens is, as I pull back, this rubber band slings backwards, and as I move forward, it propels me forward with that rubber band effect. That's another sling that I don't have up here that I'm adding now. But you've got to have the balance between posterior and anterior to get that combination of that propulsion phase that many people who are one-sided don't have. So they're missing an element of speed and free energy.